Okay, last class we stopped at this example 2, and we have introduced you the principle of work and energy. So basically, when you see the question asks you to use principle of work and energy, you write the changes of work equal to the changes of kinetic energy, right? And what do work? How to create work by the force? As long as the force go parallel with the distance, you generate work. Du equal to F ds. Okay, the work and the distance must parallel. If it's not parallel, then you get negative. For example, force and distance, they are opposite each other. This one you get negative work. This one you get positive work. Okay, let's look at example number 3. See if you're able to solve. Yeah. So example 3, you can solve using chapter 2 equation, which is F equal to ma. So since we are now in chapter 3, you are forced to use principle of work and energy. For a short time, this crane lifted 2.5 megagram beam with a force of bracket 28 plus 3s square kilonewton. So this force changes with the displacement. S is the displacement. Determine the speed of the beam when you have risen 3 meters. Also, how much time it takes to attain this height starting from rest. Okay, so you're given the one picture with the crane with a steel bar of 2.5 megagram. Okay, so before start, make sure all the units are synchronized. For example, megagram change to kilogram so that you don't make mistakes. Okay. So because we need to know some of the forces at a certain before it start, before start and after it reach 3 meters, what are the force need? You need to know the range of the force. So by taking F equal to bracket 28 plus 3s square kilonewton, you put in B 28 Newton. When it reach 3 meter, force will be this 9 multiplied 327 plus 28 will be 55 kilonewton. Okay, so you calculate at S equals 0, you get 28 kilonewton, and the weight is 2.5 megagram or 2500 kilonewton. 25, okay, 2.5 megagram will be 2500 kilonewton. This one you multiply 9.81, you get roughly 24 something Newton. Right, 24 something Newton. The weight itself is about 24 kilonewton, and the force pulling the bar up before it start from S equal to 0 is 28 kilonewton. So there is an imbalance of forces. When there's an imbalance of forces, you will generate motion. So you just prove that actually it's going up. The crane, the object is going up. Right? So you can solve the acceleration of this one using chapter 2 equation F equal to ma. Okay, this is just to check. This is just to check. So the weight and the force is in balance. So it just tell you that there's a motion happen. Then you draw free body diagram. the object, the steel 2.5 megagram with two rope, two cable pulling at both ends with the force and W. Okay. So you know that as long as the force is going up, so the distance going up is positive. So force, this F will create positive work. However, this weight going down, but the positive direction go up. So the weight multiplied by the S will give you negative work. So this one will do negative. You use principle of work and energy. So you write delta U equal to T2 minus T1 plus delta U equal T2. Transform this one, half mv square plus delta U equal half mv square. Put the there. This is one. This one, look for forces. In here, you only have two, F and W. Okay. So it tell you the velocity before it start from rest. So start from rest 0. But you still need to write the equation. You still write the equation. Then you just cancel. Become 0. You can write V1 0 from start. And you cancel. So you need to find the speed. Need to find. Okay. Then the rest you just substitute lah. Okay. Half mv squared. F multiplied by the distance traveled. Why you need integration? Because your force is in equation form. Okay. Why you need integration? Because your force is in bracket 28 plus 3 s squared kilonewton. The unit is kilonewton. So integrate df if minus force to generate positive negative work, so negative ws. So you do the integration. Do integration, you get this one 28 kilonewton. You can pull power 3 to the front 28. This is two integration. Two integration. One is 28 s and one is 3s cubed divided by 3. Then this one weight you calculate weight 2.5 megagram or 2500 multiply 9.81, you get 24.52 kilonewton. You put in there, multiply S and half mv square. You don't know the V2, you just maintain the. So when you integrate, there's only one unknown inside the equation. There's only one unknown, right? So in terms of S, right, in terms of S, so it asks you when you reason as S equal to 3 meter, so you substitute 3 here, you get the V. V you have square, so when you square root, you get positive answer and negative answer. So you need to justify which value is positive, which value is negative, which one is useful. For this one, go up positive, so you choose the positive value. Okay. So you substitute there. Okay, this step, it doesn't substitute the 3 meter first. It will just develop the equation first. Then you stop at square root equation. Then you substitute 3 there. Just to, even though you substitute 3 there, also you arrive at the same answer. Right. So you get velocity is positive side 5.47 meter second. or three significant figure. Okay, now once you know your V, you can calculate its time, right? Does the acceleration constant? Does the acceleration constant? So if you don't know, you can use chapter 1 equal to ds dt. Okay, you can derive equation because you're not sure whether acceleration is constant or not. So you use v equal to ds dt. So this is your v equation just now. Your v equation just now. You just the head, the square root become 0.5 here. If you don't like fraction form, okay. Move the t to left hand side. Move s to right hand side because s must put together. This whole bracket here contain s. So you need to put the s together, pull the t to the left side. You put in integration sign, you get the time. And s here, you integrate from 0 to 3. 0 to 3. The rest is mathematics, so I just give you the answer. Okay, so you get the time is 1.79 seconds. Okay, so the integration step, you go and check. Go and check. If you're sure, go and check. Okay, catchy part here is you need to know what is velocity definition, v equal to ds dt. Why the 3 Newton motion equation cannot use here? Because acceleration is not giving here. You are not sure whether the value of acceleration is correct or not. So the more confirmed way or more confident way is you pull out the definition for velocity because the velocity is in the equation form. Right. Okay, example 4. Example 4, you have somebody slide down from A point to B point. And you seeing this kind of question, you see curve already. So when you see curve, you should be able to draw where is your t, where is your n, and then write the acceleration acceleration equation. An equal to v square over rho, at equal to dv dt of v dot. I'll write that one first, put at the side, just in case you need it. And you need it because why? You see there's a y there, y equal to something x squared. The radius is not given, so you need to use the rho equal to something divide something with the x with the differentiation equation. Okay, now you are given the mass of a boy, 40 kilogram, slide down from smooth water slides. Here it mentioned the smooth water slides. So smooth water slide means you can ignore the friction force in the free body diagram. However, they always have a contact forces with this. Don't ignore it. You need to put the normal force for the boy. If he started at rest at A, determine the speed when it reached B and the normal reaction on the slides exerted on the boy at this position. Means you need to show the answer in the free body diagram. Where is your n? Where is your n? Okay. So how to draw free body diagram? So this is from A point when it slide down. Of course, if you don't know how to draw this one, you just draw a box or draw a circle or ball, draw something that represent human. Right? So we're focusing on the butt here. So normal force is the purple color. Okay. So because this is a curve motion, so curve motion we have normal and tangent direction. And W always pointing down from the centroid, from the center of the object. So always have W, normal force at the boy backside. So this one is at B. So when you reach from A, you reach B, it will become like this. Normal will point up. This is a tangent direction. Weight will point down. Normal force will point up. Okay. So this will be the scenario of this object. Always practice how to draw free body diagram. Practice. Okay. So before it reach B, we use principal work of energy. Principal work of energy, you write delta U equal to T2 minus T1, then you rearrange T1 plus delta U equal to T2. Then you put in half mv square plus delta U equal to half mv square. So the work, you find out whichever do work. So here, normal force do not do work because always 90 degree. But the weight here do work because got angle. Got angle. So you write the principal work and energy. Modify a little bit according to the question. For example, A and B become 1 and 2 become A and B. So I will pay attention to the notation you write in your answer. If you write 1 to 2 and in the diagram there's no 1, 2, I will circle this one, I will circle this one. Depends. Sometimes I'll give you marks, sometimes you don't have marks. But usually if this is 2 marks, then I will circle 1 and 2. If you do not write A and B, only you get half of the marks. Substitute. So NB do not do. So you put in the data. W equal to mg. The S here is a position changes. Is not because the weight is going down. Weight doesn't care how long the slider is. The trick here, calculating the length of these slides. Weight doesn't care. Weight is vector. Vector multiplied by the distance it traveled from original. For example, W is only interested from A point to 7.5 distance, here to here. Always point down. From here, it travel from here to here. Okay, here to here. So the changes of distance is 7.5. So that's why you put 7.5 here. Okay, you only look at what is the early position and final position for the work. Work only interested in position. It doesn't matter the distance traveled, sliding or touching. Then if you see this equation, there's only one velocity there that you need to solve. So you get VB equal to some value. Once you get VB, so VB, you know at this point, your VB actually is your tangent direction. This is a curve. So when you draw tangent curve, tangent diagram, so tangent go this way. This one actually is your tangent velocity. So you can do equation of motion here. So you can do two. One is in F equal to ma. and F equal. So in this case, because we know that you're given the equation of this one, you sure need to use it. So you need the normal direction acceleration equation. F equal to ma in normal. So normal one at B is NB positive go up in a normal direction. However, for W is negative because normal positive pointing into the curve. So weight is negative. M continue to carry. AN equal to V square over rho. You already know the V just now. This V equal to tangent velocity. Rho you calculate from the equation, right? So rho is this equation. Bracket 1 plus bracket dy dx square power 2 over 3 or 1.5 divide by double differentiation of your y equation. Okay, and the one is not square. Previously got student ask do the wrong one. You square the value here. This is not square. It's double differentiation. Okay, so if you see y equal to 0.75x squared, you differentiate one time, will become 2 multiplied by 0.075x. Differentiate one more time, will be the 2 multiplied by 0.075x, right? So you have, you do, and then you substitute the x coordinate, okay? You will get 6.67, huh? Okay. Once you get the row, you substitute in, you get your NB. Put it inside there. Cancel the, not cancel lah. You do the solution with the NB. Okay. So the question asks you to reaction very soft. Huh? If the question asks you acceleration, then you need to call F equal to ma in tangent direction. Then you have normal direction of your acceleration, tangent direction acceleration. You have two vector, then you can find resultant with the angle. So this one do not proceed with the acceleration. But if this one come out in the test or final exam, you need to pull out F equal to ma in tangent direction, find the acceleration of the magnitude, the resultant of acceleration, and then the angle. Okay. So example 5, you see pulley system. When you see pulley system, automatic, you need to calculate the LT first. When you see pulley system, write LT equal to L1 plus L2, and then time differentiate 0 equal to V1 plus V2. Then you integrate dt again, you'll get acceleration 1 equal to acceleration 2. So these are the standard procedure. Okay. Every time you see pulley, you need to do this one again. You need to find the acceleration or velocity, the differences between A and B. Okay, you're given a mass of two bodies. B is heavier than A. Determine the distance B traveled when it released from rest to the point where the speed becomes 2 meters per second. You need to find the SP here. So you find the LT first. LT equal to SA plus 1, 2, 3, 4 SB. LT equal to SA plus 4S. You get FA equal to minus 4SB. You integrate one more time, you get acceleration. Okay. So it means if you release from B, B go down, A will go up 4 times faster than this speed. This one go down, this one will go very fast. And the datum is SA positive go down, SB also positive go down. Be careful on the datum, yeah. Okay, then you redraw the free body diagram for this system. You draw for free body diagram for A to find the tension cable for this one. So A will give you WA and tension T. So this T will go here, go here, go here, go here. So same for the B. So you can see free body diagram on the far right corner here. So W, B, and the reaction here, and tension cable here. Use principle of work and energy again. Changes of equal to changes of energy, kinetic energy. So here you expand the equation because you have two body. So you have kinetic energy for object A, kinetic energy for object B, what time for after. Okay, then you expand the equation and ready for substitution. Okay, T equal to half mv square. Then this one, what do work? The weight is doing work. There's no extra forces here. The whole system. So weight A do work, work B also do work. Here we put positive first. Positive first. Then only we judge whether. Okay, so now we assume both body go down, the weight pointing down, but we know one of the object will go up. So VA from the rest, you can cancel. VA, VB also 0. You start from rest. So anyway, you still need to write. You still need to write this one out. Then you cancel. You draw an arrow 0, draw an arrow 0. Or you can write V1 0, V1A, V1B equals 0. Okay. Then you have all this lah. You calculate the weight. Calculate the weight. Put in the delta S for A, delta S for B. Then this side you substitute S first. You have C of A. VB, you know, in this case, VB already tell you is 2 meters per second. So you substitute over here, you only have one unknown, three unknown here, three unknown, SA, SB, and VA. So these three unknown you can extract from the pulley system equation. So you link A and B with the pulley system equation, LT equal to 4SB plus 1SA. Then you time differentiate, total length doesn't change, dl dt 0, ds dt get velocity, t get velocity. So minus 4 VB equal to VA. So this is just tell you this logic. If B move down, move A move up. Okay. Substitute VB because you know VB, right? Substitute VB 2. So you know your VA. Your VA is minus 8 meters per second. What I mean by minus means is go up. In free body diagram, there's no negative. It's only showing the expected motion. Negative only appeared in your calculation. Okay, recall just now the equation. You have BA, substitute here. Anyway, this one is square. It still give you positive value. Now you want to solve between SA and SB. SA, SB, you can solve using the same equation also. Meaning, if you pull one SB, you pull one SB, you'll get 4 SA. I mean the ratio. Okay. Can So from here over there, substitute this one in, and then SA and SB, we're using the ratio of this one. Meaning you pull one SA, you get 4 SB. Substitute here, you get 1 SA, substitute back if you want. Or you can substitute SA equal to 4 SB. Then you get SB. The question asks you B. B. So you solve for SA. And you'll get positive value. Okay. So this example also can solve by chapter 2 equation F equal to ma if you want. But this question demonstrate you can use principle of work and energy. Next, we move to power and efficiency. Power linked with work. All right. Power linked with work. And you put work within a time interval, you take work divided by time, you get power. So new equation for today. Power equal to du dt. What is the unit of work? What is the unit of work? Joule per second. Power is joule per second. So we know that du equal to force multiplied by the distance traveled, two vector, F multiplied by the distance traveled, dr. So you put inside there F dot dr. So dr dt also v. So when you take force multiplied by velocity, also get power. There are two approach to find power. You can use energy or use work divided by time, not divided, differential by time. Or if you're given force, you have velocity, you can straight away take V multiplied by the force, you get power. In general, joule per second also equal to watt, W-A-T-T, watt. Okay, 1 watt also equal to 1 joule per second, also equal to Newton meter over second. 1 Newton meter because work is force multiplied distance. Okay, Newton meter over second. Efficiency is a comparison, is a ratio between your input and output. Usually you're comparing with your input. Maximum value for efficiency is 1, which is 100%. Ideal case is 100%. So the ratio of input output maximum, you get 1. If you won't be 2, you won't be 3. Maximum is 1. Unless you are developing a new sustainable equipment that give you more and more energy, for example, nuclear energy, your efficiency will be than 1. Okay, so just remember you take out divided by input. Efficiency, you can take power, put anything that give you output or input. It's just a ratio. In this case, we use power. The rest you read. Sometimes also use energy, divide by energy. Okay, let's apply the efficiency or the power supplied by the man in 4 seconds. This question can be modified, become a robot, a remote car, RC car, or remote control robot pushing something. So the man push the 50 kilogram crane or box with a force of 150 Newton at a certain angle. So you know that when certain angles, remember to split the force into X and Y. When you see something with the angle, split into X and Y first. Then you solve in X direction or Y direction. Determine the power supplied by the fan when the time equal 4 seconds. So when you given time, usually you need to calculate power already. Power is work divided by time or force multiply velocity. Here, okay, coefficient, kinetic friction is 0.2 and the crane is at rest. Okay. This question give you kinetic friction. If the give you static and kinetic friction, then you need to be full already. If the question give you mu s or static friction, mu s, what does it mean? This is normal force. Let's say the box move to the right, the friction force will go against. So friction force will equal to mu Sn. If the box start to move, or the box tendency to move, then you use mu s. Okay, this friction that you use mu s is the friction force that hold the object. Don't let the object to move. But if the object start to move already, means this value reach the maximum value already, and the object start to move. Okay, so just be careful. If you have kinetic friction, then Kn, this one, the box start to move already, start have motion already. So the question can expand, become finding the power just enough to start moving the box, or you will see in statics impending motion. Impending motion means it start to move. Then you use mu s. Okay, but this question, example 6, it asks you to start moving already. So we start to use mu k. Draw free body diagram and equation of motion at the same time. So application of F equal to ma from chapter 2. And because you need to find power, you need to find work done. So you draw free body diagram, weight point down with the external force 150 Newton at the corner, with the friction, with the contact force. Okay, and it should be anywhere. It can be anywhere. You can put anywhere as long as under the object. Okay. So, and then we define x to positive, positive, motion go to the right. Then we start to calculate because we want to find the velocity and acceleration. So want to, in this case, want to find acceleration. So F equal to ma, the object do not move up. So F equal to ma, the result normally will give you the value of n. You can find the value of n because a0, and you balance up everything with the w, with the magnitude of force here. N minus F sine theta minus W equal to MAY. So you are given a ratio here. Theta is here. So you're going to find the y-axis. So it's hypotenuse, opposite and hypotenuse. So you are using 3/5. Huh? Theta is over here. Sine is 3/5. So N equal to minus, because it's going down, the force is going down in y direction. Minus W go down. There's only one unknown, so it give you the N value, the contact value. Okay. After you find this one, because this one got friction, automatic, the next step is to find the friction. Okay. Then you work for F equal to ma in x direction. So F cos theta equal to F friction minus F friction equal to max. You substitute the value in. Here, use ratio. Use the ratio. Cos is 4/5. So you can find your AX. So AX in x direction is 0.078 meter per second square. And since you have a constant value acceleration, you can use 3 Newton equation, 3 Newton motion equation to find the distance traveled by this force. Okay. As long as you understand the steps, value can change in the exam. Okay, so this slide is applying F equal to ma, y direction, x direction, to solve for the unknown n and the acceleration. After you find n, you can find friction. After friction, you find acceleration to that particular direction. Okay, so once you have find that one, because this is a constant acceleration scenario, you can pull any equation that from the 3 Newton motion equation. The easiest one is the first one, V equal to VO plus ACT. You have the AC already. Time you don't know. Time is given. Time is 4 seconds in the question. So VO 0, you manage to find the velocity after 4 seconds. When you have velocity, you know that power equal to force multiplied by V. This one, force is a vector, V is the vector, they must also parallel. So you get your V. Once you get your V, you can take F multiplied by V. These are two vector, F multiplied by velocity. They are two vector, must go parallel. Same principle as work. Oops. Okay. Dot products always go parallel. Dot product go parallel. So F cos theta, cos again 4/5. Just now, the unit is in watt, joule per second, or Newton meter over second. It is power. Okay. Okay. So force and velocity, they are vector. Dot products, you only get value when go parallel. I multiply I dot I, you get 1. But I dot j get 0. Anything that 90 degree to each other gets 0. But the cross product is different. Cross product have to be 90 degree to each other. Then only you get value. Okay, I think this is the last example. Okay, example 7, I'll go fast. You just observe what is the method, detail you observe. Then we go for a short break. Okay, example 7, you have a motor. You see question. So hoist, lift, cranes, so that acceleration at point P, acceleration in point P here. This P acceleration is here, so this one will rotate to the coil to rewind the wire. Okay, 1.2 meter per second. Determine the power it must be supplied to the motor at the instant P have velocity 0.6. Ignore the mass of the pulley and take coefficient at the. When you see the question give efficiency, the next steps, write the equation for efficiency. You write efficiency equal power output divided by power input. You get 1 mark for that. Always write general equation. If you see anything on the question, like for example, you see efficiency, you write power output divided by power input. You get 1 mark for the equation. Okay, you need to determine the. So here you see pulley, you should able to calculate the tension for the cable. Here, you're given the mass over here. You can draw free body diagram for this one. If you want, if you don't draw also can. You can just tell me what is the tension cable over here. All right, you just draw a square, W point down, and then 2T go up. Because 2 cable, 2T. So mg 35 multiply 9.81, get the Newton. Divide by 2, it will give you tension cable of each one of this one. This cable will be same as this cable. This cable joined to the